But Dick made a nice guess at a title for me, the upper atmosphere, and it's in the same vein as the upper atmospheric research satellite, which really looks at the middle atmosphere, so I put middle atmosphere in. A little bit of going back over time. Okay, just a little bit of context here for those of you who don't have gray hair. Back in the mid-50s, I lived in Beirut, Lebanon, and one of the things that came up in the English language newspaper there very often were small articles about space shots or rocket shots in the U.S. and the Soviet Union. They have a lot of those. So I started getting conditioned to the space program at that point. And then back in a little bit later in the 50s, back home, the big thing in the news at breakfast every day was seeing rockets blow up. In 57, we had Sputnik, which had major impact on a lot of things. And also one other aspect of what went on at that time. The school I was in had bought a 16-inch Casper telescope, which was mounted on a truck in Louisiana. It was being driven up to Connecticut. As it went across the George Washington Bridge, the police pulled it over. They thought it looked like a cannon to shoot cruise jets. In high school, in my junior year, we had physics, and what we had was PSSC physics. One of the Sputnik launch, a big effort to redo physics and put it in a better version. So that was one important thing at that point. Then 1960, I remember being back at parents' place in Princeton and went out to the Princeton battlefield, and there were crowds of people out there looking at Echo 1 going overhead. We could see it going by. It was big enough, it was bright. People were really into that. 1960, a year later, that summer, had an NSF-sponsored program during the summer. So we're not doing that RU program for the graduates, but rather for high school kids. That was a big effort to get people into things. And what I was doing was on atmospheric science, so leading this way, and Vincent Schaefer, who did the first cloud seeding, was ahead of that. Then that next water. So my first aurora. So quite a few of them. This is in Connecticut. We had a habit of seeing things at low latitude. Christmas time that year, I went to Vermont, visited my friend Al Parrish, and he set up things. We looked for the Oscar 1 satellite. So again, getting space things early on. Then I note that Engine 3 was launched in '62, as O'Brien was the person on that. And of course, many of us were involved with O'Brien here. Then in '64, I got involved in undergraduate research. Not a big thing in that date, becoming much more important now. I worked with John Knoxon with 6300 angstrom airflow. That's been with me for decades. Then started here in '65, working a lot with Dave Criswell, calibrating photometers, UV and visible. We were aiming at over an Aurora 1 satellite. Okay, after Aurora 1, with my master's on that, then in encouragement from my roommate Bob Shallon, went and talked to Bill Gordon about doing something combining Arecibo research with my photometers. He introduced me to Herb Carlson, and so Bill wanted further me to talk about science. So what did he do? He gave us 50-yard line tickets to the Rise Texas football game. I don't think either of us had a clue who won the game. So went down to Arecibo, took 4 photometers that Bob Ether had used. He used them on a NASA aircraft, and which plane came to fame when it landed in Greenland and got messed up with looking for a lost atomic bomb. Anyway, Bob was on that spacecraft, and I inherited his things afterwards. Took them to Arecibo, and then also started learning about incoherent scatter. Took a year's worth of data along with other people who we've been seeing here, Bob, Rich Baby, Bob Harper, and Luis. And analyzed the data. And what So for the science side of that, we're looking at the effect of dissociative recombination as the source of the 6300 nanometer aircraft at night. And then, so the radar and the comets went together well for that. Then look for the pre-dawn enhancement of the red line. Big deal in those days. And once we subtracted the associative recombination component from the total, there it appeared, very standard. Also, the fiber line saw that enhancement at that period. Then, I love taking photometers places. Took my photometers down to southern Argentina, Puerto Deseado. My father decided to have fun and send me a guidebook. He sent me the Voyage of the Eagle. Very good description of the region. There were 6,300 observations, but without the ionospheric observations to go with it, we could not sort out pre-dawn enhancement there. And it looks like pretty soon there's going to be, as conjugate points, the magnetic conjugate points move, it looks like pretty soon there'll be an attempt maybe to do this just south of Buenos Aires, putting in an ISR panel. And then got involved with a number of the heating experiments at Arecibo after that. And in 72, I became the second visitor to go to the Chattanooga radar. So this was a small scatter radar, a little bit smaller than Arecibo. This is just north of Fairbanks by Coca Flat. So it's under the Oval generally at night, and equator wood off the top of the Oval in the daytime. Now the second visit there, again I took my photometers, and one of the things you're seeing here, I'm highlighting names in blue from people from Rice, but there are a number of people you meet as you go along and figure in your life for many years after that. On that trip, I met John Merriweather, who shared a hotel room for 2 months. I'm looking for post-sunset enhancement at Chattanooga, so we're looking at electrons leaving about New Zealand coming in the roll zone. Well, we had a few quiet nights, and it looked like I found it. 2 kilos of paper were never sure. But I did also see on quiet nights there was a stand at low level 6,300. Okay, then moved to SRI. When I left being a visitor there, and so I was at SRI for 15 years, on and off. And on my trips to Alaska, met my wife, who would like to have been here today, but just had her knee replaced. So she's recovering and couldn't make the trip. So I worked with Rich, Bob Robinson, Bob Sharon, and then Bob Sharon was in the next lab. Also spent a little time in a lab in France, in Grenoble, with colleagues there with European influence, got a radar. And then took 2 years out to be Astronomy program director at NSF, which was fascinating. And at Chattanooga, we did a lot of the role in magnetosphere science. Looking at conventional electric fields in relation to particle precipitation. All half now, but new at that point. Looked at enhanced plasma lines. They looked at instabilities in the E region that led to extreme heating of the electrons. And looked at, on the daytime, getting the F region dragged into the cup, went over the polar cap, and then out in the evening. So that was done with millstone and ice cream. Program director at NSF, worked with Herb Carlson, so he's coming back in my life there. I was involved in recruiting Rich Banky at that time to look after the incoherent scatter facilities, and then later he recruited Bob Robinson. So it's good getting a good overview of the field, learning something about how government works. And while there, looking for things to do as well. Got involved in creating the incoherent scatter database, which later turned into the CETA database. So something totally different than the research, but important to the field. and also became involved in the Incoherent Scatter Working Group. That had been going on for a while, and the goal there was to take the Incoherent Scatter Radar, these very expensive facilities with have things that get a tremendous amount of data, and trying to use them together to get a global view of things. And of course, then when I left NSF, I found out who my real friends were. Thunderstorm radar, so in '83, Thunderstorm became the most forward Incoherent Scatter Radar. So Polar was moved from Chattanooga to Thunderstorm, and the point was that it was under the polar cup during the day, and then the polar cap at night. So it was a different view of the roll zone. So we're able to look at different aspects of the electric fields and its mapping into the magnetosphere. One thing you have on the cusp with a lot of soft electrons coming in, we got electron temperatures of about 5,000 degrees, very high. And then soft precipitation on the polar cap and strong meridional winds. Okay, well, one of the things, I love the Incoherent Scatter Radar and everything that it did. One of the things that bothered me is we were not seeing many graduate students. We were not creating new researchers. And so on top of that, I moved to Utah State, Physics Department, and CATS, the Center for Atmospheric and Space Sciences. This is my Bear Lake. The lake we have here is rather beautiful. And this was our Bear Lake Observatory. And the white thing you see in the middle is where I had a Fabre Perel. Actually, my red one. But this time with a Fabre Perel. So we were able to look at the winds in OH. So we're looking at about 87 kilometers. And the temperatures got a nice climatology of that, limited in time. And look at 6,300. Back to that. We were hoping at mid-latitude with the 6,300 to see SAR-Ox and what was going on there, the temperatures involved. But what did stand out, we never saw those. What did stand out, however, was we had very strong thermospheric winds to the west right after sunset. It should be to the east. So to get that reversal, that meant we were getting sub-auroral, very strong sub-auroral electric fields and ion drag at this mid-latitude start. Okay, from the Fabre Perel, well, not the Incoherent Scatter Radar. So I want to get back to my radar work. Well, the way to do it at the university is to build an ISO, but a Rayleigh scatter lidar. So we're doing Incoherent Scatter ion to an O2, basically. And so I put this together at USU with equipment from John Merriweather again, and Tom Wilkerson, probably none of you know. And we looked at the ionosphere of the mesosphere from 45 to 90 kilometers. This we operated for 11 years, and probably the densest data set achieved in mid-latitude with Rayleigh LiDAR. We had over 5,000 hours of data and over 900 nights. Our biggest competitor now in 20 years has only just reached about 500 nights. We had a dense set of data. Some of the things we looked at were temperatures, gravity waves, not-lucid clouds, and I'll show you more on that in a moment. Secular change, what was going on? We saw changes in the temperature up there 10 times what's predicted, but we only have 11 years of data, so what does it mean? Now looking at some of the data of sudden stratospheric warming, which we were seeing at that latitude up in the mesosphere. So the core stratospheric warming, we were looking at the mesosphere core. Okay, I said not-lucid clouds. In some ways, this was one of our more spectacular results. What you're seeing there, the white clouds there are not-lucid clouds overloaded. These are at 50 miles up, 80 kilometers, a little bit more. It's a high-latitude phenomenon. Logan is at mid-latitude, about 42 degrees. And so anyway, we saw them for the first time in June 1999. It created quite a bit of a stir. One question you have to ask is, Was this really the first time they'd occurred of a logo, or had they been occurring for a long time and no one knew what they were looking at? Who knows? But what struck people at that point was the implication of seeing them meant that at 84 kilometers, which is the altitude roughly of these, it had to be about 150. That'd be about 150 degrees Kelvin to occur, which is way below normal. Big talk about climate change and what was happening. We went back to our data. We found another case from 4 years earlier where there would have been no visible. It was midnight, and what we saw, that's the cloud coming down very thin. Then we got the temperature wave with an amplitude of 20 degrees. And that is what caused low enough temperatures to get that. Then generally we put together a climatology of temperatures. And what I'm showing here is the next thing we did was build up to build a new facility that was much more powerful. The typical range goes from about 45 kilometers to 90, and that's what we had for 11 years. There's the climatology. And what we're doing now is extending it down and up in altitude. We're doing this by having 4 huge mirrors, 2 lasers going, and the rest of the system. This is part of the construction of that. What you see there pointed out is the yoke for the telescope being lowered down into the observatory. Huge building. This is the thing running a couple of years ago. You see 2 beams going up. You see controls. We can tilt the thing 45 degrees and turn it asthma. Results from a couple of summers ago showing results up to almost 110 there. We've got to 114. You see a lot of wiggles there. Those are real. The uncertainty at the bottom is less than 1 degree K and about 10 higher up. Those are big gravity waves going on and lots of variations, and how they differ from MSIS. Details which I will be happy to talk about. And so, what's next? So the next thing is to cover that full altitude range, get some observation campaigns, reduce the data down to temperatures and absolute densities, see if we can do winds with it, commence regular observations, and do the new science of whatever we see in that. What I'd love to do after that is develop a comparable type of LiDAR, same capability, but much smaller, using some of the new technology, and something to be much cheaper that a number of countries could afford to build, so we could get a network of these around the world. And then, of course, the last thing I have there is I'd like to find a good success and leave all this to. Thank you.